It is my pleasure to introduce today Chris Carberry of the Explore Mars Foundation. And he's going to introduce the foundation and what they're doing in advancing the human exploration of Mars. Chris Carberry is former executive director of the Mars Society. He held various positions related to space exploration and advocacy. And please give him a warm welcome at Google.
Thank you, Boris. It's great to be here and great to be at Google, which I know has always had a great interest as a company in space exploration and innovation. But as Boris said, we've started this is a new organization, Explore Mars Incorporated, which was just founded about 3 months ago. The whole purpose of our organization is to stimulate innovation, private sector innovation to stimulate Mars technology and space exploration technology, and trying to bring the different parts of the space community plus the technical community together and trying to find new ways to promote space exploration. And we know for a fact, as I mentioned, Google has had an interest in Mars. You certainly have, with the April Fool's joke a few years ago, Virgil, teaming up with Virgin and Google and having the Mars mission. And then Google Mars, of course, which has turned into one of the more spectacular tools out there that pretty much anybody in the Mars community needs to use if they want to, instantly find imagery of Mars. So we know that Google has certainly an interest in Mars. And as I mentioned, the technology innovation in space, we also know that Google is a natural audience because of your input, your participation in the Lunar X Prize, the Google Lunar X Prize, which is a really spectacular program. If you're not familiar with the program that you're sponsoring, $30 million going to trying to land lunar rovers on the moon, which is, I believe, the largest prize, other than another prize that Robert Bigelow is running. This is the largest prize ever offered for space exploration. So we knew we wanted to come here and talk at Google because of the intense interest your company has in space exploration and trying to move the process forward. Now, one of the big things we want to promote with Explore Mars is the concept of Mars prizes. Now, this concept has been around for years. People like Robert Zubrin, the president of the Mars Society, back in 1996, proposed the concept, it would be a $20 billion prize trying to motivate private sector to send humans to Mars. Other people like former Speaker of the U.S. House of Representatives Newt Gingrich has also been a proponent of it, and he's actually been a proponent of it fairly recently, within the last few years. He's been pushing it hard. And the concepts come out in popular science fiction as well, with Gregory Benford writing an entire book about the concept of a Mars prize with a $30 billion prize in the Martian race. Thing is, the concept hasn't gained a lot of traction, probably because it involved everybody was proposing $30 billion prizes, and nobody was quite ready to pony up $30 billion to get this thing moving. But as we were starting to create Explore Mars, we realized we don't need $30 billion to start Mars prizes. We can do it for substantially less because we don't necessarily need to aim for getting the people to Mars immediately. There are a lot of things that we can be doing right now, technologies that are going to cost a lot less than $30 billion, a lot less $1 billion. There are things we can do right now that cost we could motivate between $10,000 and $100,000 and onward. As I just said, one of the first things we're going to do is create a series of these prizes, the first of which, the technical prizes, is the In Situ Resource Utilization Challenge. And the premise of this is, if you're going to go to Mars and you're going to have any sustained settlements on Mars, or if you want to send a mission to Mars without bringing everything with you, and if you brought all the oxygen, the water, the fuel, and the food, you're going to have an amazing amount of mass. And that's going to add to mission complication and a lot to the price tag of the mission. So one of the things we want to promote is trying to get the private sector working on in situ resource utilization. So we're going to start this year. Probably within a month, we're going to do a pre-announcement, and in the fall do the formal launch of a $50,000 prize to start off with, to try to get teams around the country teaming with universities to come up to build reactors that'll use a simulated Mars atmosphere to create fuel. Now, once they do that, we're going to have that pumped into a rocket motor that one of our sponsors will provide, and we'll fire the rocket. Now, this concept has been discussed before. Robert Zubrin and others have created these devices, these reactors, and the concept's been around since the 19th century. But what we want to do is start pushing the technology forward. We're not going to reinvent the wheel here, but there are a whole bunch of utilizations for this over time. The first of which is something that NASA's been considering. It's the sample return mission. There's a lot of talk about doing a sample return mission between NASA and ESA. And the problem with doing that is to do a sample return, the concept of sample return is to send a robotic probe down or a lander down to scoop up some Mars soil and rocks and rocket it back up into the Mars to orbit and send it back to Earth. Problem is, you have to land a fully fueled, if you don't have in situ resource utilization, you have to land a fully fueled rocket on the surface of Mars. And anybody who's followed the history of robotic probes landing on Mars knows it's been probably 50% or less, but then a lot of complications. And when you add the whole problem of landing a fully fueled launch vehicle and landing it on the surface, that adds to the complication and the hazards tremendously. So it'd be much more useful if you could actually create the fuel when you're on the surface. That'll reduce the launch mass, that'll reduce all the not all the complications, but a lot of the complications of actually landing it on the surface. So our concept is for our prize to have teams actually focus on this challenge. We want them to create reactors that are as small as possible, utilize or consume as little energy as possible, and try to match the specifications that will be required for a sample return mission. So this one we're going to be launching in the next few months. We'll have more details about the specifications that teams will need, but it'll be open to pretty much everybody in the United States, American teams, but they will also be required, if they are not a university team, to team up with university students. So we can make sure we also get students involved with this, involved into real projects, things that are actually needed, in the near term with NASA. NASA hopes to do this in the next 1 to 2 decades, hopefully within the next 1 or slightly more decades. We're hoping this will be speeded up. But one of the ways to speed it up is for groups like us and private groups around the country to start doing the innovation. Because one thing I've learned in doing space advocacy for years, we can wait around forever for NASA to start doing things. One of the big arguments against going to Mars is we're not ready for Mars. There's so much we don't know about it. We need to learn to know how to do this. We need to learn how to deal with radiation issues. We need to learn about how to counteract microgravity. Problem is, a lot of it isn't being done or being done adequately. So that's why I think this is the perfect time for the private sector to start at least taking off, challenging themselves to address some of the issues or the technologies that we can do for a limited amount of money. So we're going to start off with this sort of mission and kind of ramp up over time. And we're kind of trying to figure out all the different technologies that we think we could challenge others to accomplish. Oops, that was going the wrong way. Sorry. And of course, ISRU for this challenge is just vital for sending people. Without this, we're going to have to send everything to Mars. That's not practical. If we ever want to actually have sustainable life settlements on Mars, we can't rely on everything being sent from Earth. It's just going to be ridiculously expensive and complicated. When European settlers were coming to the New World, and if they had to rely on European ships sending all of the supplies here in order to settle the New World, obviously it would have never been settled. The only reason the New World was settled is because we could live off the land, and we can do that on Mars, and that's what we're really hoping to stimulate over the next year or so. Once we get this project going, the first stage, we're going to do a phase project, and hopefully in the next stage, we'll actually be able to motivate teams to create flight-ready hardware. That's the goal. And whether it's being used by NASA or some private entity, and there are a lot of private entities out there right now who actually want to do this sort of thing, we will be able to create the technology that's needed to do it. Oops. Another one of the concepts we're doing right now, and I'll get to some more of the technical ones in a moment. Another thing we're launching within the next 2 weeks is an education initiative. We're teaming with companies like Aerojet, and Aerojet's also sponsoring the ISRU challenge, but also NASA Spaceward Bound over at NASA Ames, Miles O'Brien, the former CNN anchor, and probably the National Science Teachers Association, to create a competition amongst science teachers. One of the big problems these days, when people are trying to promote space in the school districts is they come up with these wonderful pieces of curriculum, but they can't fit within existing curriculum standards. They're very rigid, and you just can't take a giant segment on Mars and stick it in because they won't have time. There's no way of getting it in there, even if the teacher wants to. So in our talks with the National Science Teachers Association, we've been kind of brainstorming how can we get Mars curriculum into existing curriculum standards. So we're going to launch this prize starting in the actually next 2 weeks. And Artemis Westenberg here, I should have introduced her earlier, who's the president of Explore Mars, will be running this education prize. We're going to see if educators around the country can actually solve this, find ways to get it legitimately into the curriculum. And one of the ways to do this is focus on the science that's already being taught. Geology, chemistry, biology, physics, computer science. All of those things are taught in schools right now. Well, you need all of those for Mars as well. So it shouldn't be that complicated, from a teacher to figure out how to work Mars into a geology class. You can use Mars as an analog and say, well, this is how erosion happens also on Mars. And by looking at Mars, we can also understand how processes happen on Earth. So there's wonderful ways of doing this. So you not only find new ways of teaching topics that are already being taught and perhaps making it more interesting to students. And I think we all know that we have a need of stimulating science and engineering in our school districts in this country. But they can also make Mars more relevant to the students. Because right now, when space exploration in general is brought up in school districts, it's not necessarily, they might be excited by it, but the relevance isn't necessarily brought to them. They're not quite sure why this is relevant to their lives. But if you can show how the same sciences on Earth are required on Mars, and you're not necessarily going off on some abstract diversion by studying Mars, you can focus that back on Earth if you want. That might actually help us kind of promote space exploration, but also just promote science and technology education, which is vitally needed. So we're going to be launching this in the next few weeks. We're going to have prizes, a $5,000 prize for the winner, plus ISU, the International Space University, has donated a scholarship to their summer program in Austria next year. Plus, there'll be 4 or 5 regional prizes of a few $1,000s, but all the winners will also have opportunities to do some cool stuff, like the opportunity to go do some field research with well-known planetary scientists like Chris McKay over at NASA Ames or Penny Boston in New Mexico Tech. They'll also have opportunities to go and see some rocket launches and other things. So we're hoping this will really catch on, and working with National Science Teachers Association, we'll be able to really start stimulating space exploration in the school district in new and innovative ways. Other things we want to do is just kind of brainstorm about what technologies we can do. I mean, what would be exciting? There are a lot of things we know are fairly natural, like medical challenges. We know there are a lot of medical issues out there. If you're going to send people to Mars, it's going to be a long trip in a weightless environment, so there's going to be problems with muscle mass and bone mass and muscle tone, radiation exposure, and other things like that. So all of these things need to be addressed in detail before we send people to Mars. And these are the sort of things that the private sector can start addressing as well, since NASA hasn't been doing it adequately, neither has most other space agencies. Finding ways to utilize the web to promote space exploration or use it in space. I know that Google has been involved in creating a network, deep space network. But there are ways we can utilize this. Dust mitigation. simple things like this that can also have a great benefit here on Earth. A lot of dust on Mars. It can be kind of wreak havoc on equipment and other things. If you breathe it in, it's going to be hazardous to astronauts. But there are same challenges here on Earth as well, you know, with people working or the military in the desert or anybody else. Things we need to figure out before we go to Mars, but also have a benefit here on Earth. So we want to try to challenge people to think about this. And Mars agriculture, very similar. It's also another form of in situ resource utilization. If people go to Mars, they're going to want to eat. And, you know, we need to find ways to figure out if we're going to be able to grow food on Mars. It's going to be a big, it's going to really hurt our efforts to settle Mars if we actually can't produce food on Mars. If we can't, then the game is up. We're going to be limited to just small research bases. And so studying this sort of thing right now is vital if we're going to send people to Mars by 2030, which I hope we can do. And Artemis and I were looking at all the agricultural plots outside in the lobby and kind of efforts you've been making there. And it was very relevant to what we're thinking here on different ways of producing food efficiently. So we're hoping to do things like this, trying to push this technology forward. Oops, wrong way. Another thing we're doing, hoping to create a larger, kind of connect the Mars community. Part of this, yeah, we're starting a magazine. It's an online magazine, but it's not going to be a typical magazine. Yeah, it'll have articles with cool people in it, but what we want to do is find different ways of connecting people within the space community and the broader community. Right now, even within the space community, people are off in their own little silos, and they don't often communicate. And you'll often have a group of scientists over here wondering where they can get volunteers to help out, you know, with various projects. Artemis and I went to the astrobiology conference in Houston about a month ago, and it was kind of funny because in their call for papers, they mentioned, you know, a topic for papers, citizen scientists, and trying to find ways to find volunteers for, you know, for research. Because there's all this data that needs to be gone through. You don't necessarily need planetary scientists or other, you know, PhDs to look at. Some of this stuff, you just need people to review. There are just thousands of images of Mars which just need to be reviewed to see if there are changes, geological changes, or evidence of water that's appeared on the surface, which ordinary people can do. But the problem is the scientific community didn't seem to understand there are these people just waiting to do it in the advocacy community or elsewhere. And we realized this is a real problem. If people in the different parts of the Mars community itself didn't even realize there were all these people waiting to work on projects, that's a problem. And if they don't even know that, they're not going to communicate well with the broader world. Most people are not in the Mars community. So, and the key to actually advancing our goals is to broaden this to a much bigger community, because we can get a little bit insulated within our own world and think that everybody else is going to have the same motivations, the same passion that we do, and they don't, because they won't unless we get it out there. So this is one of the key points of Exploration Magazine, trying to do this, mostly in an online format, and just try to connect people. And, you know, we've been looking at things that Google has done and other companies, you know, in other areas, and hoping we can work with people like you and other people to try to find new innovative ways to get people together and work, provide volunteers to projects, point people to real things they can be doing in the space community that they might not have otherwise known about. So we're hoping this is going to be launched this summer. It'll start off small, but we're hoping to kind of build on it, you know, over the next few months. Other things we're doing, programming, technical programs, science and engineering programs, as well as policy stuff. This year and next, we're going to be doing a Mars Airplane Symposium. The concept of sending an airplane to Mars has been around for a while, but it's kind of gaining steam again, that you can actually fly airplanes on Mars. There is enough atmosphere to do that. It's a little, the aerodynamics is a little bit different than here on Earth, since the atmospheric pressure is so much less. but you can do that. It can provide some unique opportunities to study Mars, and not to mention some spectacular views if you can actually fly an airplane on Mars. We're also doing an agricultural workshop next spring, hoping to actually partner with people in the agricultural community to brainstorm this. Because once again, this is where the space community tends to insulate itself from everybody else. They'll start talking about how to grow food on Mars or elsewhere amongst themselves, but don't actually communicate often with the people who have devoted their lives to growing food here on Earth. And there are some amazing scientists working in the agricultural community that have nothing to do with space. They could have a lot to say. They could benefit the space community on this if we ever asked them to do it, which that's the problem. They often don't. So we're hoping to start connecting these communities as well by getting the NASA people together with the agriculture people and see if they can brainstorm, because sometimes the best ideas don't necessarily come from the people you expect. NASA's not necessarily going to come up with the best ideas independently. They might, but they may not as well. You never know. And the more people you can get thinking about concepts, the better. That's what we're hoping to do. We're also going to do a bunch of policy stuff coming up. You know, I don't know how many of you know, but we have a new space policy that's been proposed. The President has proposed getting rid of the Constellation program and focusing more on private sector activities, but with the goal of getting to Mars, but with kind of a far-off date. So we're going to be doing a lot of political work and trying to speed that up and improve the project. We like a lot of things in it, but the problem is it's drawn out over such a long period of time. We feel it doesn't have much chance of survival in the political world, in the real world, particularly since the heavy lift vehicle, which they want to do, the decision for that's not going to be made until 2015, right before the end of the president's second term, which makes it extremely exposed to cancellation. So this is the sort of thing we want to do, kind of get really active in policy as well, and try to find different ways of getting out to broader communities. You know, most people aren't going to come to an event like this or, to a conference. We're going to make use of webinars and other mediums to get the word out to other individuals who might be interested. And this is the sort of thing we want to kind of get your input on. Right now, since we're a new group, we want to listen to people like you to see if you have ideas, what we can do to get the message out, use technology, social mediums, to get to reach people we might not have ordinarily met. We don't want to be kind of chained in by the old ways of doing things that a lot of the space community still is kind of locked into. We want to fully embrace the new technologies to get the word out and just make our case and get people excited about space technology. Oops. So, I'll actually get to this at the end. I'm going to kind of do a few more slides, but I actually do want to hear what you think, because this is one of the primary reasons why we are here. We want to hear your opinions. If you think there are things we should be doing, prizes we could run that would stimulate space technology or help promote the message of getting to Mars. I think that's one of the most important things we can do right now. We don't have all the answers, and that's why we want to engage people who aren't necessarily part of the space community to get your ideas and see what we can do and what you think might be an interesting way to engage people. Because right now, we are at an interesting time period in history. Regardless of what NASA does, a lot of interesting things are happening at the moment. The private sector is starting to explore space in ways that it had never been able to before. I don't know how many of you saw the launch of the Falcon 9 the other day from SpaceX, and we just toured there yesterday. It was pretty cool watching, all the fabrication of the rockets, and it was great. But wonderful launch of Falcon 9, and Elon Musk, who runs the company, is going to be, if he continues to succeed, will be servicing the International Space Station, but his goal is Mars. You have Virgin Galactic, who's about to start sending space tourists up to suborbit, but they also have an interest in Mars, and even just kind of by evidence of Virgil, the April Fool's joke that you guys did with Virgin, both companies have an interest. And the thing is, we now actually have the capability of doing private mission to Mars if the right people came together. This is entirely possible. We are no longer in the age where this is necessarily going to be done by the government or government exclusively. And so, if you were to team Google with Virgin, but if you also teamed with SpaceX, that would be an incredibly powerful combination. I don't know if you'd call it, we'll leave it there. I don't know if you'd call it Virgil-X, kind of sounds like a bad pharmaceutical, but that sort of combination could actually get people to Mars over the next few decades. With the resources that Virgin the company, and Google has teamed with SpaceX, who is already launching, is already beginning to launch vehicles, who has an extreme interest in getting to Mars. We could do this in the private sector, and we could probably do this in the next 15 to 20 years if the right people came together and decided to do this. It's not necessarily going to cost the $50 or $100 billion that, or $500 billion that NASA has projected. And frankly, probably will be done much more efficiently. People like Elon Musk have said that he could certainly do it given the time and the resources, and those resources don't necessarily need to come from NASA or any other government space agency. At any rate, that's pretty much all I had for the formal part of my talk. I just wanted to find out if any of you had any questions, or if you have any suggestions how you think we could actually better promote this message, or prizes or programs that you think we might be able to do to get the message out, or advanced technologies. Yes.
Well, that is the right kind of fall short. One thing that's occurring to me is historical parallels. The 19th and early 20th centuries, where people were exploring darkest Africa, the North Pole, the South Pole. I actually don't know. When I was reading their stories, I was much too young to think about things like how they got sponsorship and so on. Maybe something there that
So you think we could use something using an example of the late 19th and early 20th century of people exploring Africa or other the Arctic, some of the great Arctic explorers. Yeah, we certainly can. It's and that has been used as an example by a lot of the people these days in space exploration. That that was a great day of exploration. Yeah, we'd already discovered America. We knew the Arctic and Antarctic existed, as opposed to in the past, people didn't necessarily know. But there was a great private enthusiasm about it, and private sector was funding that largely. Another great example, which kind of in the same spirit, was early aviation, which is being used a lot as an example in space exploration, because particularly with the X Prize, that early aviation wasn't driven by the public sector, by government, by the military, until World War I at least. It was driven, or after World War I, this is really when this took over. After World War I, it was the private sector that was promoting advancement of technology with all these private prizes. The one that motivated Charles Lindbergh to fly across the Atlantic. Other prizes that were offered, for speed or flying around the world. And there were a whole bunch of other ones. There were Arctic prizes as well. So you're actually got it right on the nail on the head here. This is the sort of spirit we want to tap into. And this is by far not original on our part. Peter Diamandis back in the 1990s founded the X Prize just with the same concept, thinking there's got to be a way to stimulate the private sector to do some of this, because none of us want to actually wait around for NASA or others, in government agencies to do this. If they can do it, great. But I think we've all seen kind of the false starts over the last, 30 years, 40 years really, since the end of, we haven't been to the moon since the early 70s. And yeah, we've done some great things since, but none of it really rises to the level of going to the moon. Back in the 60s and the early 70s, people thought we were going to get to Mars by the early 80s. We missed that goal by quite a bit. And it's going to be a miracle if the government is able to get us back to the moon or anywhere by the 50th anniversary of us landing on the moon. Now that I find to be pretty pathetic, that this is turning into some great historical feat, which I'd line, you can compare to the pyramids or something. And I think this is really sad if people start thinking that the moon landing is kind of similar to the pyramids, that something that some ancient society did, that despite the fact that there are still people who walked on the moon around today. I just talked to one of them yesterday. And so we need to make this real in their lives, and that's one of the big problems as well, making it real, because a lot of the young people growing up have no real personal bond to real space exploration because all the good stuff seemed to happen before they were born. And we seem to be completely incapable of doing it now. So maybe NASA will do it, but I think more ways we can simulate the private sector to just take it on, the better. And I think, the innovative, the brain power, the innovative spirit just in this campus, could do an awful lot to promote this, because just amazing people here, amazing people in kind of a 10 square mile radius around here that, could really contribute to this effort.
I was curious, is Mars the best option to live off of the land, like you were talking about as far as planets in the solar system?
You mean compared to the moon or other planets?
Right.
Yeah, well, the ones we can get to that we know about at the moment, yes. The moon has no atmosphere. It's completely exposed to, the sun and radiation. Plus, the atmosphere on Mars, as I mentioned, I didn't mention, but that's what we're going to be using with our In Situ Resource Utilization as a CO2 atmosphere, so we can use that to create, if we bring hydrogen along, to create oxygen, water, and fuel. But we also know there's water on Mars. So if you have easy access to water, you don't even need to bring that. You can just create this stuff using technology, chemistry we've known since the 19th century. And interestingly, the Mars, the Phoenix lander, which landed a couple of years ago, yeah, found water ice, at least near the polar regions, 1 inch below the surface. It was kind of one of these funny things. I was talking to the principal investigator, Peter Smith, about this. And, of course, the polar lander landed with retro rockets, and it had this big scooper on it. And they were hoping to dig down, at least half a foot or a foot and find this wonderful discovery of ice. So they landed and they looked around. They didn't see any ice. They pointed the camera underneath the lander, and the retro rockets had actually cleared away soil and exposed water ice. So it was one of these things almost like a cartoon. You look around, you look under you, and there's the ice. And he mentioned this was disappointing because they were hoping to at least have some sort of effort in finding it. But the fact that the retro rockets were actually able to clear away enough soil to expose the ice means it was 1 inch below the surface. So if you can gain access in other places, we're not likely to send our first human mission to the Arctic regions of Mars. But there's plenty of evidence that there is other access to water, and there may even be liquid water, subsurface liquid water. A lot of evidence now that it's coming, there is, and you can see with some of these cliff faces that there have been outpours of water from these liquid water, and some recent examination of some images they took a few years ago of a particular cliff face compared to just one very recently showed that this has happened within the last few years. So this is actually happening. This isn't something that happened like 3 million years ago, when they say, oh, it's in the recent past, 3 million years ago. Well, yeah, that's great. It's recent in geological terms, but not in our terms. But no, this happened within the last 2 or 3 years. So there very well could be, when we send people to Mars, particularly with the correct drilling equipment, they very well could reach water right there on the surface and utilize that. So that's another reason why it's, you can actually live off the land, the atmosphere, the resources, and there's good evidence we can actually grow food in the soil. There's a few things we have to work around there, but that's one of the reasons why we're also hoping to focus on this, look at what we know about the soil composition on Mars, and start finding ways to overcome perhaps some of the challenges. Yeah, I actually heard somebody say that Mars soil would be particularly good for growing asparagus. So, but you know, once you can grow things, you can also manufacture things as well. You know, it's not just about food. You can grow, you know, it's about manufacturing. Bamboo has been people think that you can grow bamboo on it, and bamboo can be used for an awful lot of things. So once you start growing plants, you can start producing stuff that you don't have to pull in from Earth. And that's pivotal. Without that, once again, we're just going to be limited to small research bases on Mars. Yes?
I don't see how the Mars atmosphere will help because the density of the Mars atmosphere is...
I can't hear you. Can you actually come up to the mic? I can't even hear. I can't hear, sorry.
So I don't see how the existence of an atmosphere in Mars would help because the density of the Mars atmosphere on the surface of Mars is actually as low as like 5 or 6 times the altitude above Himalayas. And so, you know, yes, there is air and most of it is carbon dioxide, but at that altitude, human cannot survive without like a mask and an oxygen tank. So in a sense, I guess you could perhaps grow food with that atmosphere, but first of all, the rate would be slow, and secondly, human cannot. I mean, it's not like we can walk around without wearing a suit.
Well, no, the humans can't walk around there, and yeah, we're not going to. Some people actually say you could grow some sort of plants even in the, without shielded, but that's very speculative at the moment. Everything will be within, atmospheres that we create. And you're right, we can't walk around on the surface, but that doesn't mean we shouldn't go. Frankly, people always say, we're not designed to go into space because our bodies aren't designed to do that. Well, I suppose you can argue that, but trust me, and I'm borrowing this from somebody else, this analogy, but we're not actually designed on living on the majority of the Earth also. Try living on, for instance, I live in Boston. If I were actually trying to live there as nature created me, I don't think I'd last too many evenings in the winter naked in Boston. We're not designed to live in most of Earth but we're able to adapt to environments. Because we're able to adapt, advance, and this is part of it. This is the part of advancement. If we never left, the small sliver of the planet where humanity originated, if we stayed there, we wouldn't be here. There would be no Google. There would be no internet. We'd be just living happily, in this very small tropical area. Because, whether you think it was good that we expanded off or not, it drove innovation because humanity had to challenge itself to overcome the obstacles. By doing so, civilization was created, pyramids are built, great civilizations all over the world were built. And, sometimes you look, well, why would we want to live there? And sometimes, I can't give you all the answers. I know passionately we should because just for scientific reasons and for just kind of the vision of humanity that we're going out there and we are kind of committing ourselves to something greater than this planet, and plus kind of preserving our humanity and our worldwide cultures, which are pretty fragile. A lot of things could happen that would, if we stayed here, could pretty much end everything, and nobody would ever remember what we were about. So there's also that element of preserving the species as well. But I think it's also going to be a great thing, as I was saying, to kind of find new innovations that are going to help us back here on Earth. That you never know, you never actually know that these things are possible until you start doing it, start challenging yourself. And so that's another great reason to go, to Mars in particular. But the thing is, Mars isn't the end goal. We're saying we want to go to Mars, we want people to go there, but we're not going to be able to look anywhere else until we start. And that's the problem. Exploring Mars really isn't about saying, we want to go to Mars, that's it, that's the end goal, it's just a great place to live, people will be vacationing there. No. We hope there are settlements, we hope people, do live there, but we hope this is the starting point where we can actually really start exploring and finding ways to overcome the obstacles, the very big obstacles that are out there preventing us from doing anything and doing real exploration. And just because we don't know how to do them now doesn't mean they don't exist.
So I just want to make sure I'm I'm not against exploring Mars, but it seems to me that the goal that we are talking about right now is eventually, hopefully, some kind of permanent settlement, as opposed to people going there either as an exploration, like what we've done in the 60s with the moon, or some kind of tourism where people just go there for, say, 1 week and then come back. And it seems to me that because sending a human being there is so much more expensive compared to, say, sending a rover. So here's a proposition. Why not do a lot more explorations with robots before we actually create a price to send a human being there? Like,
Well,
why not make a much cheaper price to have private institutions send a robot there?
Well, I think it's great to have private institutions send a robot there. I'd love us to do it, but it's actually not correct to say, and people say that sending robots are more efficient. Actually, no, they're not. It is cheaper to send one rover to Mars than send people, no question about it, but it would take an extraordinary day. If you wanted to get the same amount of science done that a human could do, it would take an awful lot of rovers. Humans do things much better, much more efficiently. Actually, probably the best known robot guy, at least in the United States, Steve Squires, Mars robots, who runs Spirit and Opportunity. Yeah, he's a big advocate for robots, but, he's quoted as saying, and he said it several times to me, that one human crew could do everything that these rovers, and they've been there for 6 years, and I can't remember how far they've gone, but, several miles. One human crew could do the level of science they've done in 1 day, probably less than 1 day, and go further than those rovers. Just walking, but they'll also have their own vehicle, so they'll be able to travel, a minimum of 50 miles a day. Humans can bend over, pick up a rock and break it open. You probably noticed it takes an awful lot of effort for even a rover to try to even get below, like a millimeter below the surface of a rock. That's not, they've been wonderful. They've been a wonderful resource, and we do need to continue sending rovers because, frankly, it would be foolish to send people there before we had this data. These rovers and landers and orbiters have been vital to sending people to the planet, but if you really want to explore and you want to do it efficiently, humans are going to do it a lot better. In the end, they'll do it for less money, because if you want real science done, if you want to get these questions answered, the humans are going to be much more likely to get it. For instance, there's a lot of circumstantial evidence of life on Mars. There's the environment's past or present. The environment may have been appropriate for life in the past. But, all the evidence of subsurface water, okay, every place on Earth where there's water, there's life. One thing. There is methane in the atmosphere. Mars can't, because of the thinness of the Mars atmosphere, it can't sustain methane for very long. It has to resupply the methane every few centuries. So they can't quite account for why this methane is here. The two ways we know would come are from geological sources, volcanoes and other things, and mostly from volcanoes, and after effects of volcanic activity and life. There could be some volcanic activity going on Mars we don't know about. You'd think we would have noticed hot spots, but there could be going on. But even if it is volcanic activity, that means there is a heat source and water on Mars, which once again points to the possibility of life. But getting back to humans, and once again I'm borrowing a line from somebody else here, but people aren't very good fossil hunters. If you sent a robot, one of these rovers, out into any particular hill, in the Badlands, where we know there are a lot of dinosaur bones, it's highly unlikely that rover would find anything. Even though we know it's just filled with dinosaur bones, we know humans would find them because we're good at that thing, and we don't have to wait 20 minutes for a change in command. We can bend over, we can analyze a rock, we're intuitive. Robots may become like that over time, but humans, at least for the foreseeable future, do things much better. And frankly, inspiration. People kind of discount inspiration. Robots, yeah, they can inspire people. People love looking at the rovers, but it's not going to be nothing compared to when the first people walk on Mars. And you can't estimate how much impact that'll have. Back in the Apollo program, particularly with education, we doubled the number of science and education degrees as a result of Apollo, because people were inspired by the fact that we were landing on the moon, and it looked like we had this, endless possibilities about exploring. I'm a big advocate for funding science education, but I don't think we would have actually doubled the number of science and engineering degrees if we had just spent the money on education. You sometimes need to inspire people, and that's one of the big problems we have in this country right now. No matter how much money we pour into science and education, if you don't have something to inspire them, if they don't think they're going to do something cool, and something that's relevant or larger than themselves, there are a lot of easier ways to go through college, a lot of easier ways to make money than going into one of these really complicated technical degrees or anything else. So since we've been endlessly talking about, we're not graduating enough science and engineering people in this country, well, because we're not inspiring our kids to do so. And this sort of thing can also inspire generations, not just here, but around the world, to embrace technology and see that there's something beyond just products. Well, I'm going to go into science so I can create this new product. There's nothing wrong with products. I know I'm in an environment that's creating products all the time, and I love them. I love Google, but there's something beyond that. And I know the founders of this company know that as well, because of their passion for space, with the Lunar Prize and the other things relating to Mars they've, pushed forward. So I think it's really important, and people underestimate the value, the psychological value as well, of sending people as opposed to robots to Mars.